Alright, we've got a Sven and Ole problem here. Sven leaves Forest Lake and travels north to Moose Lake along I-35. And at the same time, Ole leaves Moose Lake and travels south to Forest Lake along the same interstate. They pass each other near Hinckley, which is 60 kilometers from Moose Lake. Both cars turn around right away after they arrive at their respective destinations, and they pass each other again near Rush City, which is 50 kilometers from Forest Lake. And the question is, what is the distance between Forest Lake and Moose Lake? Alright, well, there's a lot of information in this problem, and let's first of all just sort of summarize it here. Let's draw a graph, or draw a diagram here too, okay? Now, I guess I should be going north-south, but pretend this is north, and we're starting out here at Forest Lake, and we're going to Moose Lake, alright? So I guess that's Sven. Sven starts out at Forest Lake and goes to Moose Lake, alright? So he's going at some rate. I'm going to call it RS. That's Sven's rate. He's traveling this way, and then we have Ole here. He's traveling at his rate, which is probably different from Sven's, and he's traveling this way. And it says that, first of all, they meet each other near Hinckley, which is 60 kilometers from Moose Lake. Okay, so let's say this is, we don't know this distance, that's what we got to find, but let's say this is Hinckley. Okay, so let's call that H. And this is 60 kilometers from Moose Lake. Alright, so this distance here is 60 kilometers. Alright. Now, the thing we're trying to find is the full distance. So I'm going to call that D. So that's that full distance from Forest Lake to Moose Lake. Alright, I'm just going to draw it like that. And so that means that this distance from Forest Lake to Hinckley is D minus 60. Okay? Because the whole thing adds up to D. So, when they first meet, Ole has traveled 60 kilometers and Sven has traveled D minus 60 kilometers. Okay? And they meet up. Alright. So, this is a rate problem. You know, distance equals rate times time. Okay? Then, so, and the thing is that when they meet, they've traveled the same amount of time. So I can actually rearrange this and get an expression for time, which is time is equal to d over r, right? I'm dividing both sides by r, so you get t by itself, and so t is equal to d over r, okay? And when they meet, they've traveled the same amount of time, okay? Because they meet at the same time. So, during that time period, Sven has traveled d minus 60, and Ole has traveled 60. Okay, so that means that the time that they've traveled, I can take d divided by r. Now I don't know r. I've just assigned a variable here, rs for Sven and ro for Ole. But let's just work with distance, rate, and time. So I can take d minus 60 divided by Sven's rate, and that is going to be the time that it takes him to get to Hinckley. Now, Ole is traveling the other direction, and he travels 60 kilometers at his rate, which is, I've just called it RO, okay? And these two things are equal because they meet at the same time. That's the only way they can meet, is they're in the same place at the same time. Alright, so there we have one, and I can actually rearrange this, okay, because what I'm really interested in is D, and this R and S stuff, I think I'd like to sort of isolate it, get it off by itself. Alright, so what I'm going to do, I'm going to multiply both sides by RS. And I'm also going to multiply both sides by 60. No, I'm going to divide both sides by 60, sorry. And divide this by 60, okay? And essentially then we will get, over here we get, the 60s cancel out, and then we end up with RS over RO. So we end up with the ratio of their rates in terms of the distances that they've traveled, okay? So you can see when I do this, see the RS's cancel out over here, and then I end up with D minus 60 over 60, okay? So now I have the ratio of their rates in terms of the distances that they've traveled. And I do that because we're given some more information that I think I can do the same thing with, alright? Because they're traveling at the same rate the whole time. We're going to assume that. They don't necessarily say that, but we're going to assume that they're both traveling at their special rates, whatever those rates are, the whole time. Okay? So let's look at the second scenario where, okay, let's draw our diagram again. So we have Forest Lake, and we come across here, and here's Moose Lake. Alright? Now, what has happened? Sven has traveled the whole distance to Moose Lake, and he's come back, and now he's at, what was it, Rush City? So it's called Rush City, which is 50 kilometers from Forest Lake. Okay? So they meet again at Rush City, which is 50 kilometers from Forest Lake. Okay? So how far has Sven traveled? He's traveled D, and then he's come all the way back to Rush City, so he's gone this distance, which is D minus 50. Okay? So he has gone D plus D minus 50. And if we, and again, they're meeting at the same place at the same time, so their times are equal. So let's have this, let's do the same thing we did up here. Let's get the expression for time, the time that they meet. Now these are different times because this is when they first meet, this is when they meet the second time. Alright, so, alright, if we take the distance he's traveled and divide it by Sven's rate, alright, that'll give you the time that they meet. We can do the same thing with the distance that Ole has traveled. He has traveled D, he's coming from Moose Lake. He's traveled the whole distance plus the 50 kilometers back to Rush City. Okay, so he's turned around and now he's back at Rush City. So he has gone D plus 50, okay, and his rate is RO. We don't know what it is. We're just going to use that. And now I've got another similar expression to what I had up here. So I'm actually going to isolate the rates over on one side, okay? And I can do that if I multiply both sides by Sven's rate, okay? And let's also divide everything by D plus 50. Alright, D plus 50. Alright, that way I get RS over RO is equal to, see now these cancel out, so that's how I got the RS and RO. That comes from this side. And over here we've got 2D minus 50. I'm just combining the D and the D. It's 2D. And then on the bottom, this should be 50, shouldn't it? On the bottom, we've got D plus 50. Okay? So now we have two expressions for the ratio of their rates in terms of the distance they've traveled. And, you know, since their rates haven't changed, the ratio of their rates hasn't changed either. So, let's put these two together. Let's take these two equations and put them together because we know RS over RO, the ratio of their rates, is the same. So we have D minus 60 over 60 is equal to 2D minus 50 over D plus 50. Alright, now we should be able to solve for D. We've got one variable. Alright, so let's do that. Let's cross multiply here. Essentially what I'm doing is multiplying both sides times 60. Okay, that gets rid of 60 over here. And I want to multiply both sides by D plus 50 and D plus 50. So that's the same thing as cross multiplying. You're just doing the same thing to both sides, and the equality still holds. So let's see, we end up with d plus 50 times d minus 60, and that is equal to, I'll get a d plus 50 cancels, and we take 60 times this whole quantity, so we can go ahead and distribute it. Why don't we combine some steps here? Alright, so that's equal to 120d minus 3,000. Alright, we got 2 zeros and then a 30, so 100 times 30, 3,000. Alright, well, let's keep going with this and finish up our algebra here. Let's multiply these two things together. Alright, so basically what we're doing is distributing this whole expression within here. So we get d squared. Now I'm taking d plus 50 times d, so I can say that's plus 50d. Alright, so basically I've taken this whole thing and distributed it to the d, and now I'm going to distribute it to the 60. So we get minus 60d minus 3,000. Ah, that's nice, because look at, I still have this 120d minus 3,000 over here. Now I have 3,000 on both sides. I can just add 3,000 to both sides, and these 3,000s just go away. Alright, that helps. Alright, what have I got left? Okay, now I got a couple of d terms here. I've got 50d and 120d. I'm just going to move everything to one side, because I've also got this d squared. So we got d squared minus 130d is equal to 0. And if I factor this, you can see I can factor out a d. Okay? So I get d times d minus 130. And in order to get 0, one of these factors has to be 0. Because to get 0, I've got to multiply something by 0. Alright, so either d is equal to 0, or d is equal to 130 kilometers. And you can see that the d equals 0 doesn't really make sense for what we're doing. They're not like Moose Lake and Forest Lake. We know are not like at the same place. We've been told they're not at the same place, so this doesn't make sense based on our problem. But this like makes sense. All right. So Moose Lake and Forest Lake are 130 kilometers apart.